All right, good morning. So today, guys, what we're going to be looking at is molarity. So remember, guys, the last few days we've been looking at how to form a solution. Okay, remember we said a solution, all right, which is a homogeneous mixture. Okay, let's write it down. So a solution, guys, which is your again homogeneous mixture. Okay, homogeneous mixture is made out of two parts. Okay, so remember, guys, there's two parts to this. Okay, it's made out of two parts. Okay, what you dissolve or what you call your solutes, okay, and what dissolves it, which is called your solvent. Okay, so for example, the solute, remember guys, let's say sugar. Okay, you dissolve it in a cup of water, so that is your solute. Okay, most of the time this one is the one in the lesser amount. Okay, while your solvent is the one that is in greater amounts. All right. So when we put our solute, it dissolves in our solvent. You form what you call your homogeneous mixture. All right. Now, so let's take for example, let's say we're gonna make a cup of coffee. Right. So to make a cup of coffee, I need 1 cup of water. Okay, I need 1 cup of H2O, and let's say I need a tablespoon. Okay, I need 1 tablespoon. Okay, of let's say coffee. All right. So this is how I make coffee. Let's just say I don't use sugar. All right. Now, the question is, how can you make this coffee more stronger? How do you make this coffee stronger? All right. Well, you can either do two things. Okay, we can actually just either get 1 cup of water, okay, and add 2 spoons of coffee. So you got 2 spoons of coffee. So let's write that down. So 2 tablespoons of coffee. We got 2 tablespoons of coffee right there. We got 1 cup of water, H2O. Okay. Or, okay, to make it stronger, we can either reduce the water. Okay. So we can either just use 1 tablespoon of coffee. Okay. So 1 tablespoon coffee. And we can just use, instead of 1 cup, we can just use half a cup of H2O. Right. So again, to make coffee stronger, it's either we add more coffee, okay? Oh, I forgot the coffee there. Or we can just reduce the water. It's the same with what we were talking about inside a solution, right? So when we talk about a solution, guys, how strong it is most of the time is the concentration of it, okay? So we're talking about the concentration of the solution, right? And there are two ways to increase the concentration of the solution, okay? So to increase the concentration, okay, let's write that down. To increase the concentration, it's either of two things, okay. Number one, you can increase the amount of solute that you dissolve, or number two, you can decrease the amount of solvent, okay, which we just saw. So again, guys, when we talk about concentration, there are two ways to make the concentration go up. It's either we increase the solute or we decrease the solvent. Obviously, this would be true in reverse. To decrease the concentration of a solution, you either decrease the amount of solute or increase the amount of solvent. Okay. So when we talk about concentration, guys, that's basically the two ways to change it. Now, the problem is we need a number. We need to know how exactly strong that is, how concentrated something is. All right. So how do we measure the concentration, how strong something is? All right. That's where molarity comes into play. All right. Molarity, guys, is simply the measure of a concentration of a solution. All right. It's a measure of basically how much solute you have for every specific amount of solvent that you have. Okay. So Actually, in reality, how much solution you have. All right. So if you look closely, guys, molarity is a measure of concentration, and we just said concentration is affected only by two things, either the amount of solute or the amount of solvent. So molarity, the formula of molarity focuses on those two things. So the formula for molarity, guys, is the amount of moles of solute, okay, over the liters of solution, which is basically the overall solution itself, okay. So again, molarity, guys, is known as molar concentration, and it looks at the amount of moles of solute over the liters of solution. All right. And previously, guys, we learned that moles, we use the symbol N for it. Okay, N. All right. So previously, guys, we said moles will use the symbol N. Okay. Since we're looking at liters of solution, guys, we're just going to use L for liters. In molarity, guys, we're going to use the symbol big M. All right. So we can actually change this formula into this. All right. So right there. So that's basically M is equals to N over L. Now, we're going to use this triangle right here on the right side to help out people who can't remember how to derive uh, chemical equations from this simple equation right here. So let's put them in the triangle. And I'm going to provide this triangle for you on your quizzes. It's going to be hanging on the wall. You can imagine it for all I care. But most of the time, this is the only thing that you're going to get for a formula. All right. So when we put this in the triangle, we're going to put the moles at the top part. So N is right here. The molarity on the bottom left, right here. And then the liters of solution on the bottom right there. Okay. So how do you use this triangle? Guys, those that are side by side, those inside the triangle that are side by side, you'll have to multiply. Okay. Again, those variables that are inside the triangle that are side by side, you will have to multiply. Okay. And those variables that are on top of one another, you'll have to divide. All right. So again, if it's on top of one another, you divide. If it's beside one another, you multiply. All right. So let's derive the equations from this given triangle. So let's try to derive those equations. All right. So for example, look, let's see how this triangle works. So let's say I'm looking for the formula for molarity, big M. Again, guys, big M is right here at the bottom left. Liters is right here, and N is right here. Okay. So where is big M inside the triangle? It's right here in the bottom left. Okay. Since we're looking for big M, that means it's unknown. You can hide it. So let's hide it because it's unknown. Right? We don't see it. So look at what's left inside the triangle. What do you see? I see N on top of the L. That means to get big M or molarity, I need to divide the moles divided by the liters of solution. And that's how you get that formula. Okay. All right. So let's try it out again. So what if, guys, this time I'm looking for moles, N. All right. So look, if you're looking for moles, so let's fix our triangle again. Again, this is M right here. So guys, I'm looking for N, or the number of moles of solute. So again, N is right there. Y'all see it? So N is right there. Okay, it's unknown. You can't see it, so let's hide it. And what do you see? I see M and L beside one another. So that means you have to multiply the M by the L, and that's the formula. So to get the number of moles, you multiply the molarity by the liters of solution. All right. And finally, all right, let's erase this again. Let's look at N. All right. Finally, guys, look. What if we're looking for the liters of solution? Okay. So again, where's L? It's right here. L again is unknown, so therefore you hide it. And what do you see? It's the N on top of the M. So to get the L, the liters of solution, you have to divide the number of moles over the molarity. And basically, this is your formula for L. All right. So again, guys, the formula for molarity is based on N being in moles, okay, and L being in liters. All right. So the question now is, what if you're not given moles? Okay. What if you're not given moles? What if you're given, let's say, grams? Okay. Or for example, liters is not given in liters. You're given, let's say, milliliters. So how do you do that? Okay. If you're faced with that problem, you have to convert those two. Okay. What do I mean? Guys, if you're, for example, given milliliters, okay, you'll have to convert it to liters by dividing it by 8,000. So again, all right, again, one more time, right? If you're faced with this dilemma, okay, if you're given milliliters, you'll have to convert it to liters by dividing it 1,000. Now, if you're given grams, okay, again, you can't use that, so you'll have to change it, okay, to moles by dividing the grams by its molar mass. All right. So let's try out a few problems, right? So let's try out a few problems applying this formula. Okay. Make sure you focus your attention very clearly so you know exactly what to do. All right. So let's look at this first problem. All right. So calculate the concentration when 2.3 moles of NaCl is in 0.045 liters of solution. All right. Again, guys, first thing you need to always do is find the given. All right, so let's find the given. All right, the givens are again are the numbers inside the problem. And what do you have here? 2.3 moles. All right, is our first given. And you should know that this is your N. So I'm going to put it at underneath N. All right. Okay, keep on reading. If you have 0.45 liters of solution, so that's going to be our L. Okay, it's fairly obvious what we're looking for here is big M, but let's just check. I need to calculate the concentration. And remember, guys, concentration is given in molarity, so M is our unknown. All right, so let's consult our triangle. Again, where is big M on the triangle? It's right here. Big M again is unknown, so you don't see it. So what do you see? It's moles divided by liters. So again, guys, big M is equals to moles N over L. And that's how you solve this. So let's just plug it in. So big M is equals to 2.3 moles, okay, over 0.45 liters. All right. So you get a calculator, you do the math, okay. So we divide those numbers. So 2.3 divided by 0.45, okay, and you get 5.11. So big M here is equals to 5.11. Now, what will be the unit? All right. So if you look closely, the moles over L will not cancel out. So you got the unit moles over L. And that is actually equivalent to big M or molars, right? So this is actually your molars, 5.11 big M. And again, guys, big M, that big M is read as molars. Okay, like your teeth, right? And that is the concentration of the solution. See it? So in this problem, guys, you should have learned how to get the given, find the formula for molarity from the triangle, and then substitute and just solve it. See it? All right, cool. Let's try another problem. Okay, for example, guys, let's say this one right here. Calculate the molarity when 0.090 moles of Na2, there should be a 2 there, okay, SO4 is added to 12 milliliters of solution. So again, let's find the given. Again, it says there calculate the molarity. Therefore, you should know that M is your unknown, okay, of a 0.09 moles, okay, of Na2SO4 if added to 12 milliliters of solution. Wait a minute, there's something wrong there. It's not L, it's ML. So what did we say? If your volume is given in milliliters, you have to convert it to liters by dividing it by 1,000. So I divide this by 1,000 and I get 0.012. And this is ill. You see it? All right. So now we can use that into our equation. So this is 0.012 ill. Okay. And then you look again at our triangle. Again, guys, if you look at the triangle, it's the same thing, right? From the previous problem, big M is equals to N over L. Big M is equals to moles is 0.090 moles over, and again, 0.012 L. Big M is equals to zero point zero 0.09 divided by 0.09 divided by 0.012, and this is now 7.5. And again, this is big M, and that's the answer right there. All right, you see it? So again, guys, hopefully in this problem, you learned that if the volume is in milliliters, that you have to convert it, okay, into liters by dividing it by 1,000. Okay. All right. Let's try another problem. All right. It says here, calculate the concentration when 18 grams of hydrochloric acid is dissolved to make 0.500 liters of solution. Again, let's do this super fast. Let's find out our unknown. Our unknown is concentration. Therefore, M is unknown. Okay. And we got zero point 0.5 liters. We can use that. So it's 0.500 liters of solution. Okay. The problem is 18 grams. Again, we have no space for grams. It has to be in moles. So we have to find the molar mass of HCl and use that to convert it. So I need to divide this by the molar mass of HCl, which is 36.46. So let's divide 18 by 36.46 and you get 0.49. Okay, and this will be moles. Right, so that's your N. 0.49 moles. All right. So now we can calculate it. Again, previously we already did this, so we know that M is missing, and we see that N divided by L gives you molarity. Okay. So big M again, guys, is equals to 0.49 moles over 0.500 moles. Oh, liters. Okay. M here is about 0.99, and moles per liter again is big M. And that's our molarity right there. You see it? Cool. All right, let's try. All right, so for this one right here, in this problem, you should have learned that you have to convert the grams into moles, okay, because you can't use grams here. You have to convert it into moles, all right? Let's try another problem. Okay, all right. Not this one, not this one. All right, let's try this one right here. What mass of FeSO4 is needed to make 2.3 liters of a 0.750 molar solution? All right, so again, guys, let's see. Okay, let's see the givens. All right, we got here 2.30 liters, so that's going to be our L. Okay, we got 0.750 molars, and that's going to be our big M. Okay, 750 molars. Okay, so again, guys, how do I know this is big M? It's because of the big M at the end. All right, there's only one thing missing, so therefore it's in, unknown. The problem is, if you look closely at the question, it says there what mass. Therefore, the answer has to be in grams. So what do you do here? Well, in this case, guys, you have to solve first for moles and then convert it back into grams. Okay, by multiplying it this time instead of dividing it with its molar mass. So let's solve for n. So again, guys, if you look closely here, n on the triangles are here on the top. So that's missing, right? So if you look closely to get n, you have to multiply the big M by the L. So n here, guys, is big M, which is molarity, which is 0.750. Now remember, guys, the big M, okay? I'm just going to write it down for now. All right, big M. And then L is 2.30 L. Okay. All right. So let's multiply that 0.750 times 2.3, and I get N is equals to 1.725. Okay. What's the unit? If you look closely, guys, M and L, they don't cancel out, so they're both there. All right. But wait a minute. Okay. Remember that big M? Okay. Guys, remember that big M is actually what? That big M is actually mole per liter. So we can rewrite this as 1.725. And then your big M, guys, we can rewrite that as mole over liters. Okay. And then the liters on the other side right here. See it? Now, if you look closely, guys, you can see that the L's will cancel out. Therefore, the final answer here is 1.725 moles. Right, and that's N. Okay, the problem is we still don't have our final answer. Why? The question is what mass? So I need to convert this by multiplying it by its molar mass. So we need to figure out the molar mass of FeSO4. So, hey Google, what is the molar mass of FeSO4? Okay, it's 151.9. So let's just go 158. So I need to multiply this. Okay, so I'm going to multiply our answer by 152. Okay, which is the molar mass of Fe. So multiply this by 152. We rounded off. And the final answer here is 262.2 grams. Okay, you see it? All right. So for this problem, guys, you should have learned that if you're looking for grams, okay, if you're looking for grams, you still have to solve first for moles, okay, and then you convert it into grams by multiplying it by its molar mass.